Welcome to Module 3, Site Suitability Analysis for the Virginia Pollinator-Smart Solar Industry Program. In this module, we'll discuss the important environmental factors affecting establishment of pollinator-smart landscapes on solar facilities. And we'll learn how to conduct a site suitability analysis to determine what types of land management practices might be needed to establish a successful pollinator-smart plant community. Those interested in a more detailed review of this topic are encouraged to read Chapter 2 of the Virginia Pollinator-Smart Comprehensive Manual, which can be found at www.pollinatorsmartva.org or by entering Virginia Pollinator-Smart Program into your favorite search engine. As we proceed, it's a good idea to keep in mind the overall goal of the Virginia Pollinator-Smart Program, which is to create self-sustaining and high-quality pollinator landscapes that require minimal maintenance in the long term. This goal can be achieved on most proposed solar facilities, but we can increase our opportunities for success if we understand the important environmental factors that contribute to a pollinator-smart landscape. Those factors include topography, hydrology, soils, existing vegetation, other relevant site characteristics, and site design, and we'll discuss each one of these in turn. From the relatively flat setting of the coastal plain to the hills of the Piedmont to the mountainsides of the Blue Ridge, Ridge and Valley, and Cumberland Plateau, topography across the state of Virginia is highly variable. Depending on where the solar facility is sited, landform can be an important factor in planning a pollinator-smart site. For example, the direction that a slope is facing, also known as its aspect, will affect the local climate and the types of plant species that can thrive, with north and east facing slopes favoring cooler, moister conditions, and south and west facing slopes favoring hotter and drier conditions. In addition, the severity of the slope can be an important factor in deciding on installation methods. In the image to the right, which shows a section of a solar development plan, the topographic lines suggest a relatively steep slope. On sloping sites like this with greater than 5% gradient, planting the site using broadcast techniques, in other words, only distributing the seed on the surface of the soils, would likely increase the risk that the seed would migrate downhill during surface runoff events following rainstorms or during periods of high winds. For sloping sites, techniques like seed drilling will ensure that the seed is buried and decrease the potential for seed loss from topographic factors. Topography can also factor into hydrology, which we define as the properties, distribution, and circulation of water on a site. And therefore, a site's hydrology regime represents its overall moisture environment, an important consideration for plants. During site suitability analysis, visual assessment is usually sufficient to evaluate hydrology regime, but a review of off-site references will also be helpful. Some sites, like the image shown top right, are at lower elevations in the landscape that will collect water, while others will be at higher elevations and shed water, like the image bottom right. Likewise, the texture of the soil factors into hydrology, with sandy soils more likely to promote infiltration and fine-textured soils more likely to perch water on the surface. Texture can be modified by soil compaction, which often occurs from the equipment used to construct solar sites. Because the airspace within a soil gets squeezed out during compaction, water is more likely to perch on the surface or run off depending on landscape position. And in both of the images to the right, the soil's been compacted during construction, and that's factored into their hydrology issues. Most solar sites will have had a wetland delineation performed at some point during the planning stages, which can be helpful in identifying areas with prolonged surface soil saturation or flooding. And as mentioned above, the design plans for a solar project will usually show topography, which can be reviewed to evaluate how water might move across the site. Project sites that are wet, or alternatively, ones that are dry, can still be successfully landscaped for a pollinator-smart objective, but more care may be needed in species selection. Fortunately, the Virginia Solar Site Native Plant Finder, the tool discussed in Module 4 that we use to develop pollinator-smart planting plans, includes a range of hydrology regimes over which species typically grow. And selecting the right species for a site's hydrology regime will be important in promoting a permanent vegetation cover for erosion and sediment control, a central consideration in site plan approval for solar developments. Soils are of course critical to plant establishment, and for this reason, evaluation of soil conditions is essential in a site suitability analysis. This should include soil sampling and analysis to determine basic soil fertility, but also to determine factors that could represent growth limiting conditions for plants. For example, the bottom right image shows a soil profile with a confining layer of dense clay that's been compacted during construction, conditions that will limit root penetration once the site has been planted. Likewise, soils with low levels of nutrients, like many dry sandy soils, will limit plant growth, as will soils with extreme conditions, like the site in the bottom left-hand corner that's been exposed to erosion of acid sulfate soils and therefore is too acidic to support vegetation. A proper evaluation of soils during site suitability analysis will identify these constraints and help vegetation practitioners plan appropriate measures to remove them. The standard agronomic approach to soil sampling is recommended in the Virginia Pollinator-Smart program. Typically, a site will be divided into manageable units of uniform soil types, which can be referred to as soil sample areas. A good place to start is with the Natural Resources Conservation Service, or NRCS, soil survey. But sites can also be subdivided by landform, vegetation cover type, moisture regime, etc. Soils are then sampled to a uniform depth, usually about 6 inches, across each soil sample area. There are different strategies for compiling samples and submitting them to a lab for analysis, but the suggested approach in the Pollinator-Smart program is the one recommended by the Virginia Cooperative Extension, which involves mixing multiple samples together from a soil sample area to form a composite, and then extracting the amount necessary to submit to the soil testing lab of choice. Many labs have specific sample containers and tracking sheets that need to be filled out for their process. Be sure to check with your lab to see what their preference is. For most Pollinator-Smart applications, we recommend that the soil testing lab provide basic nutrient content, pH, organic matter content, and soluble salts. If your soil testing lab provides it, be sure to request an analysis of the data along with recommendations for the proposed planting regime. One of the most important factors to consider during site suitability analysis is vegetation. An existing vegetation assessment should include an inventory of all species present on site, as well as any plant species growing on adjacent land that investigators have permission to access. This involves walking the entire site and documenting any species found as well as their relative dominance. Scientists frequently record relative dominance using a qualitative scale like few, common, or many, or they might use a quantitative value like percent cover. The Pollinator-Smart program also recommends mapping any problematic weeds or invasive species, as well as any areas with beneficial vegetation. For example, the site shown at bottom right has several areas of the invasive species beefsteak plant on the adjacent property around the edges of the proposed solar facility. Likewise, the site bottom center is a proposed solar project within a fallow agricultural field that's been overtaken by pigweed, a species that's not listed as invasive, but is known as a problematic agricultural weed. Knowing the presence and extent of both of these species will help vegetation managers develop a targeted management approach in the future. A thorough existing vegetation assessment will also identify any areas of beneficial species, like those shown at bottom left, that could be used in project planning for conservation or enhancement. Other characteristics that should be noted during a site suitability analysis include existing wetlands or open water habitat, nearby pollinator habitat, and any nesting habitat such as open areas of well-drained soil for ground nesting insects, adjacent forests or edge habitat for birds and insect pollinators, and any cavity nesting sites like snags, fallen logs, or woody plants with open piths. These are all factors that are referenced in the scorecards for the Pollinator-Smart program, and for more information on the scorecards, viewers are encouraged to review Module 7. And finally, a thorough site suitability analysis should include a review of the site design. Most solar projects will have a set of engineering drawings that can be reviewed for information about how the project will be constructed and what constraints the construction plan might impose on a Pollinator-Smart planting plan. For example, some solar facilities are constructed with wiring that is strung above ground between the panels rather than buried, which would affect the ability for planting contractors to access the corridors between the panels. Likewise, narrow panel spacing might exclude certain types of preferred equipment like seed drills, and a low panel height would limit the types of plants that can be grown in the panel zone. The site plan will also be helpful for the planting contractor to identify available access points and any other important implementation factors like staging areas for equipment and materials. Okay, that concludes our discussion of site suitability analysis for the Pollinator-Smart program. Thank you so much for tuning in. If you have any questions at all about the content presented here or any other aspect of the program, please drop us an email at pollinator.smart@dcr.virginia.gov. We'd love to hear from you. And we'll see you in the next module.